My name is Brianna Connizzo, and I'm an assistant professor in biomedical engineering here, and I'm going to continue talking on the thread of healthspan. So it's no surprise to anyone here that the ability to move is really critical to living an active and healthy lifestyle as we get older. Regular exercise decreases blood pressure and the risk for many different diseases, from diabetes to stroke to heart disease, etc. Exercise can also reduce stress and anxiety and also improve muscle strength, which means that older adults can live a more independent lifestyle for much longer out in the community. This link between mobility and morbidity is in fact so strong that one of the strongest predictors of lifespan is actually the speed at which you walk. So great, we'll all just keep walking marathons and then we'll live to 100, be centenarians, right? Well, not so fast, right? Because the key to being able to stay mobile is your musculoskeletal system, and without that, it's not going to work. Efficient movement requires healthy joints, right? That means bones, cartilage, muscle, and my favorite tissue, tendons. Tendons connect muscle to bone, and they're required for joint stability, but they're also really critical for transferring and storing energy during movement. The unique thing about tendon is that they're super strong. So the Achilles tendon in your calf, for example, can hold up to 10 times your body weight. And considering its size and cellularity, that's really impressive. They do this because they have a dense extracellular matrix that's primarily composed of collagen, and that encompasses all of the cells, which are their primary biologic capacity. Tendons are generally considered relatively inert because they have so few cells, but in fact they're actually highly responsive to exercise and can do high levels of adaptation, turning over their matrix and making them stronger or weaker depending on the situation you're dealing with. My lab studies this adaptation process, so we're interested in understanding how tendons respond to mechanical forces or exercise and how that can eventually lead to a stronger tendon. In our lab, we use a technique called explant culture, where we take live three-dimensional tissues and we keep them in a custom-built bioreactor and can essentially simulate exercise on them and then see how they're able to synthesize new proteins or degrade the proteins that they have. One of the more interesting findings we had recently is that the ability to adapt to different changing function is actually lost with aging. So on the left side, you can see the young groups, the left column, where they have this very nice sort of sweet spot in the middle where they maintain their normal synthesis and degradation. But in aging, you don't really have this sensitivity at all. And in fact, no matter what type of exercise you apply to them, they're always reducing their matrix synthesis and increasing their matrix degradation. So what this means is that those training regimes that we're trying to give our older patients, strength training protocols, they might not actually work for changing tendon function or strength. And furthermore, they actually could cause more damage and disease. So my lab has been sort of tasked by me to figure out why this dysfunctional adaptation occurs and how we can prevent and reverse it. And so the way that we're doing that is by focusing on this cellular and subcellular hallmarks of aging and figuring out which of those hallmarks actually have an impact on the ability to synthesize and remodel the matrix. So we've been studying a couple of these really heavily, and so far we've found that senescence, which you'll hear about in a future talk, is actually really important to this process and can disrupt ECM remodeling. We've also found that signaling between different tissues, like muscle and bone, for example, which is critical to coordinated exercise responses, is disrupted in both an age and sex-dependent manner. And then finally, something very simple like the processing of nutrients like glucose is disrupted in aged tendons. And this means they can't build the amino acids that make proteins required for extracellular matrix. So hopefully we can figure out which of these cellular processes are linked to ECM remodeling, and then we can help older adults live healthier and active for longer. Thank you.